Alright, ladies and gentlemen, welcome back. Today we will be looking at Module 1, Lesson 2, the multiplication of numbers in exponential form. So today what we want you to be able to learn by the end of this lesson is the use of the definition of exponential notation to make sense of the first law of exponents. There are actually 3 laws of exponents, but today we're going to be looking at the first and a little bit of the second one. So another thing that we're going to look at today is using the first law of exponents in order to simplify exponential expressions for the division of exponents. And again, that's just a modification on the first law of exponents. So if you would, go ahead and open up your binders and we'll get started. You need to be on page 5 of your binder. And like I said, we're going to be looking at the basic properties of this new concept of raising a number to a power. Now that number that I referenced is called the base, and the power is also called the exponent. Now there are 3 basic properties, and we will be discussing all of them between this lesson and the next lesson. So let's take a look at how this first property works. Now the example says how to multiply different powers of the same number x. If m and n are positive integers, then what is x to the m power times x to the n power? Now we have 3 variables here. We have x, we have m, and we have n. So let's give these some values so you can see actually what is happening here. So let's say that x is 3, m is 5, and n is 7. So I'm just rewriting this here, because that is our example, x to the m power times x to the n power. And so now we're just substituting these values for the variables. So we have 3 to the 5th power times 3 to the 7th power. And so what actually happens here is, since we have the same base of 3, we just carry that over. And now, because they have the same base, we take our exponents and we add them together. So we have 3 to the 5 plus 7 power. Alright, so staying on page 5, I'm going to work several examples with you. Feel free to do exercises 3, 4, 5, and 6 on your own if you would like, but I'm just going to work the 4 shown here with you. So exercise 1, we have 14 to the 23rd power times 14 to the 8th power. Now some things that we need to take a look at in order to make sure that it is possible to actually add these exponents together. The first thing is it an exponential form? And yes, it is an exponential form. We have a base and we have a power for each one. Also, are the bases the same? We're looking at the bases. We have 14 and 14, so yes, they are the same. Now all we have to do is put it together. So we have a base of 14, and now we are adding our exponents together. So we have 14 to the 23 plus 8 power. Now if we take a look at exercise 2, we have negative 72 to the 10th power times negative 72 to the 13th power. And remember what I said earlier, that the exponents need to be positive integers. The exponents need to be positive whole numbers. So looking at exercise 2, our base is what is negative. So our first basic principle is not compromised here because our exponents are still positive. So all we do is carry over our base. We have negative 72, and we raise that to the 10 plus 13th power. Now skipping a few of these exercises, looking at exercise 7, let b be a number, b being the variable, so it could actually be any number. And the example says b to the 94th power times b to the 78th power. Now because we don't know what b represents, that is our base, so we're just keeping that the same. So b to the 94 plus 78 power. Now last but not least, we have exercise 8. let x be a positive integer. So if negative 3 to the 9th power times negative 3 to the x power equals negative 3 to the 14th power, we are trying to find what this variable x is. So they have the same bases, negative 3 and negative 3. So if we write this using our first basic principle of exponents, we have negative 3 to the 9 plus x power, and that equals negative 3 to the 14th power. So what we're trying to do here is figure out what this x is. 9 plus something equals 14. And you should know by now, I would hope, that 9 plus 5 equals 14. Therefore, our x that we are looking for, our variable x, equals 5. If we look at page 6, exercises 9 and 10, the question asks what would happen if there were more terms with the same base. Write an equivalent expression for each problem. Now again, we have that little checklist that we have to go through. First, we have to see if they are in exponential form, and yes, they are. We have a base and we have an exponent for each option here. Now the second thing is, are all the bases the same? And the first base is a 9, the second one's a 9, the third one is a 9. So yes, they are all the same. So we can still apply the basic principle, the first basic principle of exponents to exercise 9. We're just going to have a little bit longer of an exponent here. So it is still a base of 9, and we are adding all of our exponents together. We have 9 to the 4 plus 6 plus 13th power. Now exercise 10, again going through that little checklist that we talked about. Yes, they are in exponential form, and yes, they do have the same base. All the bases are 2. So now we just need to write that out using our first basic principle of exponents. So our base is 2, and we have an exponent of 3 plus an exponent of 5 plus an exponent of 7 plus an exponent of 9. So your final answer should look like 2 to the 3 plus 5 plus 7 plus 9th power. Now in your binders, I would like for you to complete exercises 11 through 17 on page 6. And I have written down our little checklist for you. Some things that I would like to point out is on number 2, are the bases the same? And just for your information, you can only add the exponents of bases that are exactly the same. In some of these you might have 2 different bases, so make sure that you're looking at those closely. Also, for exercises 14, 15, and 16, think about different ways that you can write these exponents. Okay, so like in exercise 14, it states that you have 2 to the 4th times 8 to the 2nd. Now those are not the same bases, so you got to think of another way that you can write 8 to the 2nd. Now there's a couple of different ways, so just think about what the product of 8 times 8 is, and another way that you can write that using exponential notation. Then you will be able to come up with your answer. So I hope lessons 11 through 17 weren't too rough for you. Looking ahead at exercise 18, let A and B be numbers. Use the distributive law to rewrite the expression in a simpler form. And hopefully you remember this from 6th grade. We need to distribute this A all throughout this entire expression here, A plus B. So what we need to do is multiply A times A, and if we do that, we come up with A squared, and then we multiply A times the B, and if we multiply A times the B, we have AB. Now all we do is we just carry along this addition symbol, and so our final answer is A squared plus AB. Now in your binders, please complete exercise 19. It uses the same distributive law as in exercise 18, so if you need to refer back to that for assistance, feel free to do so. So now moving on to the second rule, our second basic principle of exponents. If you look at page 7, about halfway down, you'll see a little box that has this statement here. In general, if x is non-zero and m and n are positive integers, then x to the m power divided by x to the m power equals x to the m minus n. Now what I would like for you to do, just right above that box on page 7 where this statement is written, I would like for you to write rule 2. To divide identical bases, you subtract the exponents. That's all we're doing here. Now, just like what we did for the first rule, we're going to give x, m, and n, our variables, we're going to give those some value. So x, m, and n, let's just use the same numbers that we did before. X is 3, m is 7, and n is 5. Now I switch those up a little bit and you will see why here in just a second. So now, substituting our numbers for our variables, we have 3 to the 7th power over 3 to the 5th power. Now one thing that you really need to notice here is that x is non-zero. It is impossible to have 0 in the denominator. So please make sure and note that. Now the reason that I switched m and n from our first rule is because x to the m power is our numerator. So our exponent in the numerator needs to be just a little bit bigger than our denominator so that we can subtract it all nice and pretty. So whenever we combine this and write it out, it looks like the base of 3 to the 7 minus 5 power. So using that principle that we just learned from rule 2, let's take a look at exercise 21. 7 to the 9th power divided by 7 to the 6th power. Again, running through that quick checklist that we were doing before. Yes, they are both in exponential notation, and they both have the same base, which is 7. So in order to answer this, we still have our base of 7. However, we are dividing. So we take our numerator, that one comes first. Our numerator, our exponent in the numerator is 9. So we have 7 to the 9th power minus, and we have 7 to the 6th power in the denominator down here. So we're taking that 6, that exponent, and we are subtracting it from 9. So our answer should be 7 to the 9 minus 6 power. Now in your binders, you need to complete lessons 22 through 24. And if you need to refer back to the examples that we did just right before this, please feel free to do so. In closing of Module 1, Lesson 2, I have written for you our 2 basic principles of exponents that we looked at today. I have them written using variables, and we looked at some examples of how to manipulate those a little bit in order to see what is really going on with these identities. So if you need to look back at those, if you need a quick refresher, please feel free to do so. And by the way, just a little heads up, you might want to remember these because you might see them very, very soon. Hope you guys have a good night.